On Friday, we did a little bit of review of algebraic numbers and how variables are used in the polynomials or algebraic numbers. Today we're going to go to the next step. There's a couple of things we're going to work with. We mentioned formulas. And the formulas were just a matter of substituting in for our variables and doing our order of operations. So if we were asked to evaluate a plus b times c minus df plus m for a equals 3, b equals 4, d equals negative 5, f equals 2, and m equals 9. What we have to do is we have to substitute those values for those variables into that expression. So a, instead of a, we're going to put in 3. Plus, instead of b, we're going to put in the 4. Parentheses, instead of c, we'll put in, oops, I didn't get the c up there, sorry. C equals 8. Instead of c, we put in the 8. Minus d, instead of d, we put in negative 5. Now that's a negative 5. To put that in, we're going to put it in parentheses so we know that it's minus a negative 5. So we isolate it, we know that that's negative. We don't lose track of that negative on the 5. Times f, we're going to put in the 2 there for f. Show that. And then plus m is going to be 9. And then from this place, it's just order of operations. We start inside the parentheses, and in there we're going to do the multiplication first. Negative 5 times 2 is a negative 10. Now it's still negative, so I'm going to keep it in parentheses for now. And notice this negative is outside of what I circled there, so that's still there. That subtraction is still there, plus 9. Now I'm still working inside the parentheses. I'll do 8 minus a negative 10. Now 8 minus a negative 10 becomes 8 plus a positive 10. So that's just 18. And then finally I finish off the parentheses by doing 18 plus 9 is 27. And now that I'm done with the parentheses, now it's positive, so I don't need the parentheses to isolate the negative or anything like that. But I do need the multiplication. The parentheses are indicating multiplication. So before I take out the parentheses, I do need to put in the multiplication symbol there. Now, multiplication first before addition. 4 times 27 is 108. And 3 plus 108 is 111, is that result. It looks like they're moving Boston here, so we'll give you guys a second to get settled into a new location before we keep going. Okay, there we go. So as y'all get settled in, the next topic, and the one we're going to spend the most time on as far as applications of variables, is going to be things that look like this. X equals 7. And of course, we know that that's called an equation, and it's named for that symbol right there, the equal sign. Now, if I ask people to define what that symbol means, most people would have a hard time defining it without using the word equals. What's on one side is equal to what's on the other. Well, again, trying to define it without using itself, we could say that what's on one side has exactly the same value as what's on the other side. In fact, we can think of it as a balanced scale. What's on the right side of the equal sign exactly balances what's on the left side of the equal sign. Now, every equation starts out in this form as a variable equals a number, or the other way around, a number equals a variable. It's called defining the variable. And it's built from there. To build an equation, we can actually use any of our basic operations. We can do addition and subtraction. We can do multiplication and division. We can do powers and roots. And those are just the types of operations, the pairs of operations we've looked at so far. There are all sorts of other operations that occur out there, exponentials and logarithms, which we're not going to get into in this course, but actually are rather important functions if you get into more advanced medicine, into biochemistry and stuff like that. Exponentials and logarithms explain the reproduction or growth of a virus, population growth, population shrinkage due to illness, and things like that. Then, of course, there's like trig functions and their verses, and other more advanced functions. For this class, we'll get up to about there. So if I wanted to build this onto this equation and make it more complex, let's just pick a number. Let's pick the number 5. We're going to add 5 to it. So we add 5 here, we got x plus 5. But now remember, this is like a balanced scale. And if we add to one side, the scale is going to tip unless we add the same thing to the other side to balance it out. So whatever we do to one side, we have to do to the other to keep it balanced. So we have to add 5 on the other side of the scale. 7 plus 5 is 12. So we have now built a more complex equation. Now, we're not usually asked to build equations. We're generally asked to solve equations. So that's the command that we're going to be used to seeing is solve. And when we're asked to solve, what it's asking us to do is to take this apart and get it back to this original form of a variable equals a number or a number equals a variable. So here, this was built by adding 5. We are going to take it apart by doing the opposite, subtracting 5. So we subtract 5, that removes the plus 5 there. But now again, that scale is going to tip. If we take 5 off of one side, that side gets lighter. So we have to take 5 off of the other side to keep them balanced out. So on the left side, we've removed the 5, so that's just x. On the right side, 12 minus 5 is 7. And we see that is what we started with. X equals 7. We have it down to that variable equals a number form. Now in this case, we built or at least you watched me build the equation. So we knew how it was built, we knew how to take it apart. The trick is being able to look at an equation and figure out how it was built so that we can then take it apart. So we might have an equation like 11 equals y minus 6. So the way we break this down is we find the equal sign. Then we identify what side has the variable on it. Here, y is on the right side of this equation. Then we ask ourselves, what's keeping y from being alone here? What's been done to y to keep it from being alone here? And so we look at this. The 6 is what's keeping y from being alone. And it was attached by the operation of subtraction. So what was done to the variable here was 6 was subtracted from it. So to solve this, we do the opposite. We take that apart. We add 6, removes the subtracting 6. And again, remember, we've got to balance that scale, so we have to add 6 to the other side. 11 plus 6 is 17. And on the right side, all that's left is y. So there we are. We have that form of a number equals a variable, or a variable equals a number. Or we might have 7z equals 63. Well, again, there's our equal sign. Our variable's on the left side, and of course it's not alone. What was done to the variable, in this case what was done to z, is it's been multiplied by the 7. So to take it apart, the opposite of multiplying is to divide. So we're going to divide by 7 to remove the 7. And again, we keep that scale balanced by doing the exact same thing to both sides. So the 7 cancels out, giving us z. 73 divided by z is 9. So z equals 9. Well, those three examples were pretty simple because they're what we call one-step equations. They were built by performing one operation and one only. But we can have equations that were built with a more complex set of operations. We might have 3x minus 7 equals 26. So here we find the equal sign, and there it is. We identify the variables on the left side, and we ask what has been done to x to build this equation. And again, to do that, we look and see what's keeping x from being alone. Well, there's the 3 and there's the 7. And the 3 is multiplied, the 7 is subtracted. And we have to figure out what order this was done in. Well, it's order of operations. The order of operations says you would multiply before you subtract. So when this was built, x was multiplied by 3, then the 7 was subtracted from it. Now to solve it, we're taking this apart. If you think of, if you've just put something together, let's say you put together a toy or a model or a piece of furniture that you've purchased, if you've just finished, if you just put on the last piece, if for some reason you have to take it back apart, what's the first piece you're going to take off? Yeah, it's going to be that last piece that you put on. So the same is true for an equation. When we take this apart, the first piece we take off has to be that last piece we put on. So in this case, the last piece that was put on was subtracting 7. We're going to take it apart by adding 7. So that minus 7 is gone, leaving us with 3x. On the right side, we have 26 plus 7 is 33. Now we get rid of the 3. 3 is multiplied, so we're going to divide by 3. 3 is gone. X equals 33 divided by 3 is 11. We might have x over 5 minus 3 is equal to, well, let's do 37 is equal to x over 5 minus 3. So again, here's our equals. Here's our equal sign. The variable's on the right side. Our variable is x, so we got to figure out what's been done to x. Well, here x has been divided by 5, and then 3 has been subtracted from it. So we would add 3 to get rid of the minus 3. So adding 3 removes the minus 3, but we have to do the same to the other side to keep it balanced still. So 37 plus 3 is 40. On the right side, the minus 3 has just been removed, so we just have x over 5. And now to get rid of dividing by 5, we multiply by 5. So 40 times 5 is 200. On the right side, the 5's just cancel out, and we have x. Now you get an answer like 200 equals x or x equals 200. You might be inclined to doubt whether you did things correctly or not. So we can all, and I'm sure this was drilled into you in freshman algebra. You can always double check your answer. So we can go back to the original equation here. 37 equals x over 5 minus 3. And we can replace x with that result of 200. I'm going to take out the x and put in the 200. And now we do our order of operations. Well, first we divide. 200 divided by 5 is 40. 37 equals 40 minus 3. And 40 minus 3 is 37. So we do get the same value on both sides. So that tells us that 200 equals x is a solution to that equation. We might have stuff like the square root of x plus 3 equals 19. I go to solve this. I look at what's been done to x. Well, here x is, we've taken the square root of x and then added 3 to it. So when I go to take that apart, the opposite of adding 3 is going to be to subtract 3. So the square root of x equals 16. Then to get rid of the square root, we square it. So the square root of x squared, the square root and the squared cancel out. We just have x. 16 squared is 256. Now there's a very subtle difference between that problem and this next one. The square root of x plus 3 all inside the square root equals 7. Now if we look at what's been done to x, the first thing that happened was the 3 was added to it. Remember, that square root is an enclosing symbol if there's more than one thing inside of it. So adding 3 happened first, and then the square root was taken. So when we go to solve this, we have to get rid of the square root first. So we're going to square that to get rid of the square root, and we square the other side. So the square root and the squared cancel out. X plus 3 equals 7 squared is 49. And then we just subtract the 3. Get rid of the plus 3. X equals 49 minus 3 is 46. We're not going to do a lot of equations with square roots and squareds in here, but in medical fields they come up all the time. If you get into orthopedics, bone strength, bone density, it comes up a lot. It comes up in our formulas for body surface area. It'll come up in our formulas for body mass index that we will use later on in the course. But we're not going to necessarily be solving those equations. We're going to be using them in formulas. But we will need to step up our equations to something a little more complex, like this. 5x plus 4 minus 2x equals 28. So here, we find our equal sign, well, it's right there, and we identify where the variable is. And we look, we see that there's an x on the left side. There's actually, x appears twice on the left side. If we're still thinking of this idea of a balanced scale, however, we see that we have 5x and negative 2x. Remember, the subtraction goes with the number coming after it. Both on the same side of that scale, which means I can just push them together into one big pile, and it doesn't change the balance of that equation. Again, I do have to remember that's a negative 2x because of the subtraction in front of it. 5x and negative 2x make 3x. Then we have the plus 4 there, and this equals 28. So this illustrates what we sometimes have to do before we can solve an equation. And one of those things is to combine on each side. Here we had the 5x and the negative 2x that we had to combine. And now in this case, there's nothing left to do except to solve, so we'll subtract the 4. 3x equals 24, and divide by the 3. So x equals 8. Now again, if we wanted to, we could go back to that original problem, and we can put 8 in wherever we saw x, and make sure we get the same value on each side. So 5x becomes 5 times 8, plus 4 minus 2x will become 2 times 8 equals 28. Now we have 5 times 8 is 40, plus 4 minus 2 times 8 is 16. We can do those both in the same step because they're separated by operations of lower priority. Equals 28. 40 plus 4 is 44. And 44 minus 16 is 28. So we get 28 on each side, telling us that x equals 8 is a solution to that equation. Well, what looks very similar to that but slightly different would be this one. (5x plus 9 equals 2x plus 17). Oops, not 17. I want to do 2x plus 20. Try that again. There we go. 2x plus 21. Makes that work out a lot better. So here we find the equal sign. It's right there. We go to identify where the variable is, and we see that there's a variable on each side of the equation. We cannot just push these together anymore because they're on opposite sides. If we push them together, it's going to involve moving stuff from one side of the scale to the other, and that doesn't keep things balanced. So this illustrates what we often have to do is the second thing that we'll have to do sometimes before we solve, and that is to make sure the variable is on just one side. Here there's a variable on each side, so I have to get rid of one of them. To get rid of one, we either add or subtract makes it go to 0. To get rid of it, we usually look for the smallest one. Here, 2x is smaller than 5x, so we're going to get rid of the 2x. Since it's a positive 2x, we'll get rid of it by subtracting 2x. So we subtract 2x, it removes that 2x. And we're left with just 21 on the right side. But we still have to take 2x away from the other side. Now remember, when we add or subtract, we can only combine things that have the same name. So the only place I can subtract 2x on the left side is from the 5x. That's the only thing that has the same name. 5x minus 2x is 3x. And we still have the positive 9. Now we're ready to solve here. We'll subtract 9 from both sides. 3x equals 12. And then divide by 3. Get x equals 4. Now again, if you got to this point and you wanted to double check, you could go back and put 4 in for x in the original equation. 5x becomes 5 times 4 plus 9 equals 2x will become 2 times 4 plus 21. 5 times 4 is 20 plus 9 is 29. 2 times 4 is 8 plus 21 is 29. So we get the same value on both sides of the equation, telling us that x equals 4 is a solution. So to review, before we can solve, there's often two things that we have to look for to make sure those are done first. First is to see if there's anything we can combine on each side of the equation. Then once there's nothing to combine or we have combined everything we can, we need to make sure the variable is on only one side of the equation. If it's on both sides, we have to get rid of it in one of those spots. Then we can solve. If both of those things are good, then we can go ahead and solve. Now again, I want to go back and review the difference of what happened here. In this first example, both 5x and the negative 2x were on the same side of the equal sign. That's why we could just combine them into the 3x. Down here, however, 5x was on one side of the equal sign and 2x was on the other. We can't just push them together and combine them anymore. So we had to find the smaller one and remove it. That's why the positive 2x, we subtracted 2x to get it to 0, to make it go away. In math, removing something means turning it into a 0. And then we might run into equations like this. Seven times 3x minus 5 equals 7. So to solve this, we would go ahead and, well, whenever we see a parentheses, it should scream at us to do something here first. We look inside the parentheses to see if there's anything to do inside of them. And there's nothing to do here. 3x minus 5 cannot be combined. It's actually just a single number. It's 2 digits of the same number. So the parentheses there is just isolating that as a single number. So then that means we need to multiply. Now we saw this on Friday, multiplying that 1-digit number times the 2-digit number. We could write it off to the side like this and multiply if we wanted to. 7 times negative 5 is negative 35. 7 times 3x is 21x. Or we can use the shortcut that most of us have been taught, which is to distribute. We do 7 times 3x is 21x. 7 times negative 5, remember that sign goes with the number that comes after, so it's a negative 5. 7 times negative 5 is a negative 35, equals 70. Now we're ready to solve the equation. Add 35. 21x equals 70 plus 35 is 105. Then we'll divide by the 21 and get x by itself. X equals 5. So this first step here kind of goes under that category of this first step here. Combine what you can on each side of the equation. So we can make these equations progressively more difficult. Rather than going step by step, I'm going to throw in some here that are a little bit tricky, like this one. 2x minus 5x plus 1 equals 14. Now to solve this one here, we need to recognize what's going on with the parentheses. We see the parentheses, and we look, see, is there anything to do inside the parentheses? And in this case, there's nothing to do inside there again. But before we move on, we have to ask, is there anything that needs to be done to the parentheses? Up above, it was being multiplied by a number. Here, it's actually also being multiplied by a number. That minus in front of the parentheses needs to be thought of as a negative 1 times the parentheses. So here we still have the 2x, but then this is negative 1 times 5x makes negative 5x. Negative 1 times 1 is a negative 1, and then we still equal 14. There's still more that we can combine on the left side, though, so we have to keep going with it. We have 2x and negative 5x makes negative 3x. We still have the minus 1, and it equals 14. Now we've combined everything we need to combine. The variable is on one side, so we can go ahead and solve. We'll go ahead and add 1 to both sides. Negative 3x equals 15. Then we can divide by the negative 3. X equals negative 5. So the difficulty there was dealing with the fact that we had a subtraction in front of a parentheses without a number there. Now let's step it up to about as bad as it can get for these equations. 3 equals 5x minus 1 minus 2 times 3x plus 4 minus 7 equals 5 times 2x plus 7 plus 2 times x minus 3 minus 5. Now this looks like a monster, and it kind of is, but as long as we go step by step, there isn't a problem here. Remember, step 1 is always to combine what we can on each side. So let's start on the left side and combine what we can there. So we have parentheses here. There's more than one parenthesis, so we're going to go left to right. Nothing to do inside this parentheses, so we're going to multiply by the 3. 3 times 5x is 15x. 3 times negative 1 is negative 3. We move to the next parenthesis. Again, there's nothing to do inside there. We do have to notice, though, that's a negative 2 there that's multiplying the parentheses. So negative 2 times 3x is a negative 6x. Negative 2 times 4 is a negative 8. Now that's the end of the parentheses, so we're done multiplying. but we do still have the negative 7 there. Now we need to go ahead and keep combining. We'll stick on the left side. We have 5x and negative 6x makes 9x. Negative 3 and negative 8 makes negative 11. Then negative 7 makes it negative 18. Equals. Now we've combined everything we can on the left side. We'll go over to the right side. Nothing to do inside that first parentheses, so we're going to multiply by 5. 5 times 2x is 10x, and 5 times 7 is 35. Look at the second set of parentheses. Nothing to do inside there, so we're going to multiply by the 2. It's positive 2. So 2 times x is a positive 2x. 2 times negative 3 is a negative 6. Now again, we're at the end of the parentheses, so we stop multiplying, but we do still have that minus 5 there. So now we keep combining. We have 10x and 2x makes 12x. We have 35 and negative 6 makes 29. Then that 29 and negative 5 makes a positive 24. So now we've combined everything we can combine on both sides of this equation. It is time to do step 2, which is to make sure the variable's on just one side. Unfortunately, the variable's on both sides here, so we have to take care of that as well. We have 9x and 12x. The 9x is the smaller one, so that's the one we're going to get rid of. That's a positive 9x, so we're going to subtract 9x to turn that into a 0. But remember, we're still a balanced scale with these equations. So we subtracted 9x from the left. We have to subtract 9x from the right. Only place we can subtract it from is from 12x. So now on the left, we still have negative 18 equals 12x minus 9x is 3x, and we have the positive 24. Now we're ready to solve. So we'll go ahead and subtract 24. Well, 18 minus 24 is a negative 42. On the right side, we just have 3x. Got to get rid of the 3, we'll divide by 3. Negative 42 divided by 3 is negative 14. And on the right side, the 3's just cancel out, giving us x equals negative 14. Now, I'm not going to go through with it right now, but we could if we had to. If you wanted to go back up, replace x with negative 14 and make sure we get the same value on each side of that equation. We will, I'll assure you that. So before we move on, I want to talk now about some basic word problems. So we might have simple solutions like Sam and Pat sell cars. Let's say Sam sells 4 times as many cars. Battery's going low. As Pat. If they sell a total of 65 cars in a week, how many does each sell? I'll give you a second to look at that, get it written down, and see if you have any insights as to how to solve it. So I know it's one of those things that you probably disliked having to do it, thought it was as tedious as I did when I first learned algebra, but I'm starting to see the importance of it now. Defining our variable, telling what the variable is. Here we have 2 things we're looking for. We're looking for Sam's sales, and we're also looking for Pat's sales. So there's 2 things we're looking for, but we only have 1 variable to do it. So it makes it even more important that we define our variable here. And figure out how to define our variable, we have to look for the relationship between those two things we're looking for. And that is given right here in this first line. Sam sells 4 times as many cars as Pat. So if we're going to define one of them in terms of the other, it would be easiest if I let X be Pat's sales, and then Sam's sales will be 4 times X. Because Sam sells 4 times as many. So then the equation I would use to summarize this relationship, there's a total of 65 cars. So Sam's sales, 4x, plus Pat's sales of x has to add up to 65. And now we solve the equation. Step 1 is to combine what we can on either side. Here we have 4x and x. And we think of that as a 1x. 4x and 1x make 5x equals 65. Then we divide by 5. X equals 13. Now, once we've solved, when we're using an equation for a word problem, once we've solved the equation, there are 2 things we need to be careful to do. One is we need to make sure we know what the variable represents. Well, that's one of the reasons why we defined it up here, is so we can remember what it represents. X represents Pat's sales. So Pat sold 13 cars. Next, we need to make sure we've answered the question completely. The question asks us, how many does each sell? We've only answered part of that. We've only answered how much Pat sells. We have to show how much Sam sells. Well, Sam is 4 times X. So 4 times 13 is 52. Sam sold 52 cars. Now we have completely answered the question. Now, I realize this is a little bit of a corny word problem, very simplistic. But it illustrates one of the 3 main types of problems we run into. So the first type is we have 2 amounts, A plus B, add up to a total. And that's what this was. Sam sales plus Pat sales added up to total sales. Another very common one is we have 2 amounts that are equal to each other. A has to equal B. And we'll see that in some cases. And the third one is a difference. A minus B equals some given difference or known difference. And that's also a pretty important one to look into. So we had that very simplistic problem there for the first example. Let's do another example that's maybe a little bit less simplistic. Like Taylor sells t-shirts, $12 each, and hats for $8 each. If Taylor sells 20 items for a total of let's just do $128. How many of each were sold? Oops, I don't want to do 120. Let's do $208. How many of each were sold? So this one looks very similar to the other one, but there's some very important differences. So let's start off with the 2 things we're trying to find, the t-shirts and the hats. And what we're actually trying to find about each of them is the number sold. So in order to express them as a single variable, I need to find a relationship between them. And in this problem, it's a little more subtle. It doesn't say that one is 3 times the other or 4 times the other or whatever. It says there's a total of 20 items. So that means the two amounts add up to 20 items. To do that, we're going to just pick one of them and define its amount to be X. The other amount is the total of 20 minus X. Then we need to know the dollar amount from each. And the dollar amount or total sales is the amount sold times the price. So for t-shirts, it's $12 each times the price of X. For hats, it's $8 each times 20 minus X. And that has to add up to our total sales of 208. So I have my 12X plus 8 times 20 minus X adds up to $208. Now we have to solve this equation. So we're going to multiply, but we see the parentheses, there's nothing to do inside of them. So we'll go ahead and distribute the 8. So the 12X here doesn't change. 8 times 20 is a positive 160. 8 times negative X, again, we think of it as a negative 1X. So 8 times negative 1X is negative 8X. Equals 208, doesn't change. We do still have things to combine, though. We have 12X and negative 8X make 4X plus 160 equals 208. Now we've combined everything we can combine, and the variable is already on just one side, so we'll go ahead and solve. Subtract 160 from both sides. 4X equals 48, and then we divide by 4. X equals 12. Now again, we need to make sure we know what X represents. X was the number of t-shirts sold, so that means there's 12 t-shirts sold. But we also have to make sure we've answered the whole question. And the question asked how many of each were sold. So we've only answered half of it so far. There were 12 t-shirts. Hats were 20 minus X or 20 minus 12. So there was 8 hats sold. So our complete answer is they sold 12 t-shirts and 8 hats. Again, I'm sure you guys have all seen problems similar to that. May have been a while, so it might take you a while to get used to them, but they'll come back to you. Wednesday, we are going to look at more word problems, but specialized word problems with solutions. Friday, because there's been a change in calendars, it looks like 2 of our 3 schools are lined up to have an in-service day on Friday. And I will send out a message to your contact person. This Friday, there will be no class on the, 17th. We will have class this Wednesday, so I'll see you again in a couple of days. For now, your homework in your book, page 49 through 50. 1 through 43, the odds on solving equations. And again, as always, if the first few seem easy, feel free to skip ahead and do some of the more difficult ones. Make sure you focus on any word problems that are in there. That seems to be the skill that is the most difficult for a lot of students right now, is translating those word problems into equations to solve. I have all your tests. I will have those graded and hopefully back to your contact person by Wednesday. So those of you that do have class on Friday, like I said, I can log in if you want me to, but we won't have any lecture or anything on Friday for you, so there really is no formal class. It gives you guys in Boston a chance to catch up from last Friday missing as well. Last Friday, by the way, if you didn't get the message, there was no homework for those of you who weren't able to attend. With that, I'll get out of here. You guys have a great day, and hopefully we'll see you all on Wednesday.